Hello the internet and welcome back to my channel. Today on the bench we have a special guest. This is an Apple ProFile external hard drive. This is a 5 megabytes external hard drive and it was sold in 1981 for $3,400, which with today inflation and everything is about $12,000. It's so impressive. This was designed to work with the Apple III first, then an interface card was designed for the Apple II, even though apparently it's pretty rare to find nowadays. And eventually the Apple Lisa was released to the market in 1983, and every Apple Lisa came out with a ProFile, a 5 megabyte ProFile. There was also a 10 megabyte ProFile being released, but that required some hardware updates. I'm not sure whether it was on the interface or on the computer, for the computer to see the extra 5 megabytes. Now, this hard drive comes with this shipping fixture printed on it, and I really don't know what that means. This is of a friend of mine, and he thinks this might have been like a service hard drive that was being shipped around the world or maybe around the US as service spare parts, as a replacement unit. I have no idea. If you know more about this, if you want to leave a comment, that would be great because I'm pretty curious. Unfortunately, I don't have a Lisa, I don't have an Apple III, and I don't have the interface card that interfaces this ProFile to an Apple II. So I can't really connect to this drive and actually test it. That being said, the fault with this ProFile doesn't really require a computer to diagnose it. So enough me talking, and let's take a look at it. Right, okay, so let's open this unit, which has been opened already by my friend. It's actually been repaired. Let me explain you what happened. The unit is pretty simple. We have the hard drive here, which is supposed to be a 5 megabytes. Then we have the actual controller board. This is the Apple board, where the signal from the Lisa comes in through this parallel port, and it's a proprietary protocol. Then we got power supply through this orange connector going into the controller board. And also we have a small 2-pin connector going straight to the hard drive. I guess that's 12 volts going to the hard drive. And finally we have, let's call it the control connector, which goes from the controller to the hard drive itself. And under this controller board, that's the power supply. Now, what happened with this ProFile is that my friend looked into that and basically found these two ICs. These are ULN2074NE. I had a quick look online, and these are like transistor drivers. So these talk directly to the hard drive, and they were visibly burned. He replaced these two ICs, he's got another ProFile, he tried the board on that ProFile, and apparently the board is working perfectly fine. The hard drive, however, apparently is not working very well, so I'm not familiar with this giant thing. Here on the side, as you would expect, there's the stepper motor, and apparently when it powers up, it sicks through all the tracks, and apparently it struggles at some point and it never gets ready, as you would expect. So apparently the hard drive is either broken or needs some help of some sort. The thing is, I really don't have an Apple Lisa or anything, or an Apple III that works with this ProFile. So even when I can revive this thing, I'll have to take it back to my friend so he can test it on his Lisa, or I'm not sure he's got an Apple III, to be honest, but it's definitely got a Lisa. For now, the problem with these units is that the power supply is not working, apparently. I don't want to plug it up and see what happens, just in case the power supply is outputting something weird. So the first thing I want to do, I'm going to remove the controller board, access the power supply, remove it, open it up, we'll take a look. Then to test the power supply, I would like to add some loads to whatever voltages are coming out of these connectors, because all the power supplies, they don't like to run without a load. So I'll set some loads on these voltages and we will see, what the power supply does, because honestly, I don't know. And the board here, for the records, is a 6560102-M, and I couldn't find the schematics, the various schematics for this board, so we'll have to work with something else, and I hope that what I found is more or less similar. So So here's the power supply. It does remind me my Apple II power supply, and I think I know why. Well, this is an Aztec power supply, exactly as the one I have in my Apple II. And again, I can see the design is pretty similar. One thing I'm noticing just immediately after opening this thing is that we have 4 reefer capacitors here. Not one, we have 4. And 3 are on the inputs, which are expected, but 1 is on the output, which I've never seen a reefer on the outputs, to be honest. So I'll have to replace this 4. Now, I'm not an expert when it comes to power supplies, but it looks like a simple design. Mains is coming here. I'm actually seeing something pretty interesting here, which is this little connector here, a little wire actually, which you can plug into 230 or 115 volts to basically convert a power supply depending where you are. That's pretty good, which means this ProFile can go all around the world and it will always work. You just have to switch the mains voltage input here. The rest of the design is pretty easy, I guess. There's a bridge rectifier here. We got some capacitor storing some energy, the main switching transistor. Then we have the main transformer basically chopping off the voltage, which then goes to the secondary part of the power supply into some diodes for rectification. We have 3 inductors here, I guess because this thing has 3 output voltages maybe. I'm not sure about that. Feel free to leave a comment if I'm saying rubbish, which is very possible. And some leveling capacitors to just make sure that the voltage coming out is nice and smooth. Thankfully, the board, the PCB, actually has the voltages on where the cables are, which is great. I don't really have schematics for the power supply, so we know that the blue is plus 12 volts. It also says 1.5 amps here. We have 5 volts, 2 amps for the red cable. The black is ground or common, if you want to call it that way. And finally, the purple is minus 12 volts at 15 amps. Is that 15? No, 0.15 amps. Okay, that would have been too much. And finally, the white one is AC OK. It's kind of weird. I thought it was like power OK, as in the power supply is ready and it's outputting voltage. But AC OK seems to suggest that the AC is actually okay. I'm not sure what the controller needs to know about that. But anyways, well, that's what the PCB says. So as I said, I don't really know what's wrong with this power supply, so I'll have to test it. Now that we know all the voltages on these connectors here, that's kind of easy. I will set up some loads for +5, +12 and -12, and then we can try and power it up and see what happens, because honestly, I don't know. Okay, well, it's a big mess of wires, as you would expect, but I think I'm ready to go. So what I've done, I have selected a different load for all the different voltages. I did some calculations. There's an app that I'm using on my iPhone. I'm gonna link it down below because it's pretty easy to use, pretty interesting. It's ohms law. I mean, it's not rocket science. Plus, I'm using this thing, which I never introduced it on one of my videos. It's a digital load. It is pretty interesting. It's very inexpensive. I think it's designed to test batteries originally, the original design. What can I do with this? It's pretty interesting. It's a digital load, so I can select a load through the control panel here, through the buttons. At this point, I selected a 1 amp. And I can connect it to whatever it is, and it's always going to be 1 amp. So right now it's connected to the 12 volts line, and it's going to be 1 amp. If I want to turn it up to 2 amps, I don't need to rewire things or add resistors, do calculations and stuff. I just push some buttons, that goes up to 2 amps, and then suddenly your power supply is outputting 2 amps on that voltage. So this is set for my 12 volts line, which is maximum 1.5 amps. It's set to 1 amp, I can change it to whatever I want. And here I've got my Fluke, which is connected to the 5 volts line. The 12 volts I can see it on my dummy load. I know you won't be able to see it from here, but I can read it. And the 5 volts is going to be here. So the next step is to plug the mains and see what happens when you power up. Time to power up in 3, 2, 1, go. Okay, well, there's absolutely nothing coming out of it. There's a noise coming from the power supply, like kind of a clicking noise. It tells me that the power supply is protecting itself. Let me see if I can record it without shorting the microphone. Oh, it's actually interesting the noise it does when I switch it off. Let me do this again. Right, this is telling me that maybe there's something shorted in this power supply. This is like the control circuitry is protecting itself. There must be some kind of overload sensor somewhere, and if there is a short, the power supply will shut down. The moment it shuts down, then there's no overload anymore, so it starts again, it senses an overload, and it shuts down again, there's no overload, and so on and so forth. Now, this is a very, very simple power supply. I don't see an IC or something to control these things. So I can only see transistors and stuff. So hopefully it's going to be kind of easy to find what's wrong with this. Now, because I suspect a short, what I'd like to try is like the basics. You know, usually you can check that the transistor is not shorted, the diodes are not shorted, the bridge rectifier is not shorted. You take a look at components to do a visual inspection before you start looking into how the circuit works. So let me do some basic checks, and then maybe we'll dig out the thermal camera and see if there's anything that warms up, which is and would be an indication of a short. Okay, here we got the power supply PCB out of the case. So I would say let's start with the bridge rectifier, which is down here. I got my multimeter in diode mode, so it beeps if there's a short, otherwise it tells me the voltage drop. I can see a diode here, there's another diode here, and two more diodes here. So the bridge rectifier seems to be fine. Now let's check this transistor. This is one of the old, I can't remember the name of the casing of this transistor, it's pretty old. And we can do the same checks here using the diode mode. Here I can see a junction, there's another junction, well that's the same. Okay, no, I don't see a short on the transistor either. So last thing I can try would be the output diodes. So we got 3 output diodes here on a heatsink. It's kind of a familiar Aztec design to have this heatsink here. I mean, again, still in diode mode because obviously these are diodes. And I do see a junction. Again, there's also capacitors around, so obviously I see them too. That's 158, and the last one is... Oh. Okay, is that shorted? Okay, well... It looks like the first on the left might be shorted here, because again I'm reading a short. Let's see in resistance mode. Well, 0.6 is the dead short. Okay, well that's interesting. Now before I remove this thing, I'd like to take a look with my thermal camera and see if by any chance that diode also shows on thermal camera as overheating. Right, I got the power supply just back into its case. So thermal camera is on. Let's power this up in 3, 2, 1, go. Okay, it's clicking as before, and yes, I mean that is the diode and its reflection on the heatsink, and the one on the left, which seems to be shorted, is actually getting warmer. So is there anything else that is warming up? Well, there is actually, and it's much warmer than the diode. Okay, so maybe it's not the diode. There's something here. 2 small resistors and then a diode here. Well, I guess we have a couple of clues here. It could be a problem with this diode here, or it could be a problem with the Zener diode here. It's kind of difficult to know, to be honest, especially without schematics. So what I'm gonna do, I'm gonna start with this diode, I'm gonna desolder it from the board, at least one leg if I can, and just test it out of circuit. And that will tell me whether this diode is working or not, and if this is working, but probably even if it's not working, I'll check these 3 components here. Again, 2 resistors and one, it looks like a Zener diode, or it could also be a diode. It says D something, D1, D16, so I'll check that one as well. Well, removing components from a heatsink is not easy, because obviously when you're using the soldering iron, the heat is being sucked away by the heatsink itself. So I had to remove the whole thing. But anyways, well, at least now I can check everything in one go. So back in diode mode, and let's check again. This is 120, 120. It's a bit higher, but it's not shorted. Okay, so the diode is not the problem here, and I guess I will turn my attention to those 3 components that I mentioned before, as those 2 resistors and a small diode. Alright, I got these 3 components with one leg lifted from the PCB, so let's check the resistors first. What is this reading? 56. I haven't checked the color bands, but 56 is one of the values available, so I guess that's probably fine. And this is reading 100, which is again, it's an available value, which is probably going to be okay. Let's move to diode mode and check this. Well, it says 1 and 4, so that's probably just a diode. I don't think it's a Zener diode. Aha, shorted one direction and completely shorted the other direction. Fantastic. Let's check in resistance mode, dead short. Perfect. So it looks like that is our problem, and probably this one is connected to that one, and that's where I was reading the short. Okay, let's remove it, see if I have a replacement. Hopefully I do, otherwise I'll place an order. Now, while I'm waiting for the replacement diode, I thought I would just check these capacitors and see if any of them requires replacement. So I've taken these out first. It's 1000 microfarad 16 volts. So let's see what my component tester says. And all capacitors on the secondary side tested spot on. Perfect capacitance and very low ESR. From a reliability standpoint, it would be a good idea to replace them, but from a functionality point of view, they're working perfectly and there is no need to replace them. Different story for the primary side capacitors. The first one I tested was a 47 microfarad capacitor and tested 60 microfarad. Now, electrolytic capacitors have a 20% tolerance, so the maximum I would expect for a 47 microfarad was 56.4 microfarad. 60 is too much. However, all the other 47 microfarad capacitors also read 56-57 microfarad, so either they're all going bad or they're just a bit off. I'll leave them for now with a black X on top so we know what to look for next time. What would you have done, considering that those are high voltage capacitors and not very cheap? Leave a comment down below. After all, these are Nippon Chemical capacitors, so good quality ones, even though only rated 85 degrees Celsius. Under one of them I might be able to see some leakage, which I can spot on the PCB as well, but it might also be some residues from the soldering though. Anyways, I think these capacitors will do for now. I spoke with the owner of the ProFile and he's happy to recap it himself if needed. And replacement diodes have arrived, so I've selected something which is as similar as possible as the one that was in the PCB. The reason is I don't really know what this is for, and the existing one is a super fast switching diode and with some parameters, and I try and match those parameters to the replacement one. I just didn't want to use a standard general purpose diode simply because I don't know what this circuit is for. So let's replace the diode, and also I've got some refa capacitors here, so I'll replace the refas as well, and then we'll test it. And as for my Apple IIc monitor repair, you will see me replacing refa capacitors with refa capacitor. Reason is, again, I have this in stock. The owner of the power supply knows what refas are, and he told me it's totally fine with me using refas. I hope they improve the manufacturing process, to be honest, so hopefully they don't explode as easily, but even if they do, they're probably gonna explode in like 30 years time. So anyways, the thing is, my friend is happy for me to use this. Once I've depleted my stock of refas, I will definitely buy something else. It's quite interesting that where these capacitors are going, you have 4 holes for the PCB, and the 2 outer holes are for larger capacitors like this, but I ended up with a smaller version. There should be exactly the same type of capacitor if I did my research right. And this smaller one fits with the inner holes, so I don't have to adapt anything. That's pretty interesting. So I believe I might have hit a roadblock, as I think I found another faulty component. Now this is a thyristor. A thyristor is an interesting device, and I only learned about those just a few weeks ago by chance. The thyristor is basically a diode, so it would flow current in one direction, but it only flows current when the gate is being triggered. Once it's been triggered, it keeps flowing. You basically have to remove power to reset it. It's kind of a transistor, but the thing is that this little thing is actually rated 12 amps, so it's usually used as a switch. Now, meanwhile, I found the schematics of this power supply, and I found that this thyristor is part of a circuit which is called the Crowbar. And it's very simple. There's a little Zener diode here. This Zener diode is rated 5.6 volts, and both the Zener diode and the thyristor are on the 5 volts line of the power supply. In the event of a power supply failure where there is an overvoltage on the 5 volts line, the Zener diode would start conducting over 5.6 volts, and as a result, the thyristor is engaged, and what the thyristor does is shorting 5 volts to ground. So the idea is, if you have an overvoltage, you rather short the power supply than send, I don't know, 10 volts to the electronics, because that will destroy the electronics very quickly, very easily. While if you short 5 volts, now the power supply should protect itself and basically shut down. If it doesn't, then the fuse should blow. If the fuse doesn't blow, then the main breaker should trip. But the idea is, you'd rather want to lose the power supply than the controller board. Now, I think I saw something weird with this component, so I just removed it and we can test it together. As I said, the thyristor is basically a diode, so the first two legs is the cathode and the anode, and I should be able to see a junction in there, but I don't see anything in one direction or the other direction, so that's pretty weird. So let's try the component tester and see what it says. And the component tester says something weird, like this 85 ohms between 1 and 3, which is cathode and gate, and the gate is the one that triggers the switch, basically, whether it's conductive or not. That being said, I spoke with the Tech Knight, and his channel is linked down below. It's an amazing channel, by the way, just go and have a look. And he basically told me that SCR or thyristors, they can be a bit tricky to test. So he recommended to do an actual test with like a light bulb or something like that and see whether that's working or not. So I've decided to test the thyristor into an actual setup, and it's very easy. Got the power supply going into this LED lamp through the thyristor and back to the power supply. So the thyristor is acting as a switch. Right now I have 12 volts going out and the lamp is off. But what happens if I send 12 volts to the gate of the thyristor should switch on basically and let the current flow, and see what happens. There you go, it's actually working. So I don't really know what happened with the multimeter and with the component tester, but apparently thyristors have the ability to be, I don't know, difficult to test. I don't know, I'm not sure what happened. If you want to leave a comment and if someone knows exactly why I wasn't able to test the thyristor, that would be great. Okay, I got the power supply back into its case and I got all the loads connected as before. The Fluke multimeter is set on the 5 volts, so if this works, we will see 5 volts on the multimeter or whatever voltage there is. Well, let's hope I haven't replugged any of these capacitors the other way around. I would say let's power it up. In 3, 2, 1, go. Still not working. He's still doing exactly the same. Exactly the same. That's so weird. That I swapped one component and that's still not working. So, okay, well this needs more diagnostic, I guess. So let's have a look with the thermal camera again, see if there's something shows up. Power supply is on. Oh, but that's the one I've replaced. It's still doing 90 degrees. 100 and something. Look at that. It's burning. Okay, well, any chance that that component is shorted again? Let's give it a go. Okay, I got the meter in diode mode, and let's check the diode that I just replaced. Shorted one direction and shorted one direction. Is it possible that that diode has failed again? That would obviously indicate something wrong around that circuit, I guess. Okay, well, let's take a look at that diode. Let's remove it and see if it's actually shorted. And it's shorted again. It basically shorted immediately. Right, okay, well, thankfully I found the schematic, so I'll have to ruminate on the schematics a bit and understand what could cause these diodes to fail in like 5 seconds. So yeah, let me have a look at that first. Right, I've been doing a little bit of troubleshooting. I might have found a lead. Let me show you. So this is the diode that keeps failing, D16, and I'd like to show you something at the back. Now this is a single layer board, so there are no traces on the other side of the board. Now this is where the diode is going. Now I got the meter in continuity mode, and if I'm probing between ground and one end, I have like something ohms, which is totally fine. If I'm probing the other end, there is a dead short. Now, that shouldn't be a dead short, because this component here, which is crossing from here to here, is a resistor. And if I'm checking this resistor, even in circuit, it's reading 100K, so this is working. Now, this trace is pretty easy to follow. It basically comes here, there is one component here, and then it goes to ground. Now, this component here, guess what it is? It's a tantalum capacitor. That's a capacitor, it shouldn't read a short. And this is not going anywhere else. It's just that resistor and that component. The resistor is not shorted, this must be shorted. Obviously, I'm reading a short here, and there's nothing else. So I'd like to remove it, and I have a feeling that that tantalum is shorted, which is not surprising. And would you look at that? There you go, that's the usual shorted tantalum. And that makes totally sense, because if that is shorted, the first component that basically dies is the diode. As soon as the 12 volts line comes up, 12 volts flows through the diode at full power, and the diode just dies. And the faulty capacitor is at 10 microfarad at 25 volts. This is also confirmed by the service manual. And what are the chances that I actually have them in stock? So we can test this straight away. Alright, so the tantalum is replaced, the diode is replaced again, and I've got the load set up already, so I would say it's time to give it a go. Take two. In 3, 2, 1, go. Yay, it's working, look at that! 4.7 volts, I got 12 volts, 11.3 actually, at my dummy load, digital load. Voltages are not great, to be honest. And we do also have minus 12, which is minus 13.6. I guess it depends on the load, and again, this is a pretty simple power supply, to be honest. So this is great, everything seems to be working fine. What I'm gonna do, I'm gonna let it running for a little while, just to make sure there are no other surprises. Then we can put it back together and see if this thing is able to power up the hard drive. Right, good news, the power supply seems to be working, the voltages are more or less there. It's a very early revision of these power supplies, there's not a single IC on it, and the voltages are a bit, up and down, but I think this is what this power supply can do, to be honest. But it looks fine, the voltages are there. When I apply a proper load, the voltages are what I'm expecting, so I think that's what this power supply can do. Now, the next step would be to reassemble the power supply, put it back into the ProFile, and see if this thing is capable of running the hard drive and the controller board. Now, before I close this thing, I'll give it a good clean, because I've been doing quite a lot of soldering at the back of this board, so I'll make sure that everything is nice and clean. Okay, I'm ready to give it a go. I'm probing 5 volts, you see 5 volts in here, just in case, to be on the safe side, and I'll put the microphone close to the hard drive, so if it starts up, you'll hopefully hear it. Okay, in 3, 2, 1, go. Well, I've got to say it doesn't sound very healthy. The head is moving, you can't see it, but I can see the head moving. When it moved, it stopped at some point. Now the LED is plugged the other way around, so I'll power it off in a second and see if we get any error messages or anything. But yeah, it seems to be working totally fine, so the power supply is definitely fixed. Let's try with the LED wired the right way around to see if we see any flashes. Let's power up now. Well, there is sign of life, and unfortunately this is where my troubleshooting ends, simply because I haven't got a system that works with this hard drive. And if I'm not mistaken, that would be an Apple Lisa, an Apple III, or there's a board for the Apple II, but it's pretty rare, I understand. I definitely don't have it. The last thing I'd like to do before calling a day would be to check these voltages. So we know that 5 volts is actually spot on, because it's measuring 4.9. So that's obviously, as you can see, I was concerned about the 5 volts, but there's no need for concern, because the power supply is perfectly spec'd to work with this load. And at this load, it works totally fine. 4.9 is totally expected. Then we have 12 volts, which is again, I think it's totally fine. I think 12 volts is plus or minus 0.6, 0.7 volts or something like that. It's much less strict than the 5 volts, I guess, for some reasons. And minus 12, I'm curious about that. It's a bit on the low side maybe, but honestly, I think minus 12 is probably used as a reference or something. The maximum output of minus 12 is 0.15 amps. So I think that's totally fine as well. Well, that's great. I guess this is it. I can't do anything more than this. I know the drive starts. Most importantly, I see activity on the LED, which means the board is alive somehow. And happy days, we fixed it. Well, I guess this is it for today's video. I do appreciate this is not really a profile repair, it's more a power supply repair. My friend tells me that this drive might need a low-level format, and apparently to low-level format this drive is not something that, you run a software and it runs. It's not for the faint of hearts. You basically have to run a specific like ROM or something like that, and which on this processor, which is a Zilog Z8, it's embedded in the processor. You can't change it. It can't be updated or anything. So apparently there is a modem replacement for the processor where you can change the firmware in it and you will run a low-level format routine. After all, this is a 1981 device. It's totally expectable that it's not designed to be easy to use. That being said, I really enjoyed this process. I enjoyed that I was kind of fooled by the symptom of the faulty tantalum capacitor. I should have definitely checked whether there was still a short after removing the diode or not. Well, lesson learned. That's why I'm here, to learn things, to improve electronics, to have fun. I hope you also had fun and hopefully you learned something. So this is it for today. I hope you enjoyed this video. If you did, I would really appreciate if you could hit the like button down below. And also if you can leave a comment, because that will tell the YouTube algorithm that you really like this channel and this video. For now, thanks for watching. I wish you a great day and I hope to see you again soon here on this channel for my next videos. Thank you very much and goodbye. Bye.